Alright, Miss Ray here. I had a request to film a video going over some more of these monohybrid cross problems. Now, note we will be doing more in class, but if you would like to watch this just to get a hang of how you solve these problems, I'll be walking us through some more. Alrighty. So, to remember, when we are solving these problems, there are 4 steps for us to go through. Step number 1 is to create a key. Creating a key means essentially figuring out what's dominant and recessive and assigning it a letter, a capital and a lowercase letter. Step number 2 is to figure out the parents. So read the problem, figure out your parents, and what letters the parents have. Step number 3 is going to be to set up and solve the Punnett square. And then question number 4 is going to be to answer your question. So let's go through these. So our question here, I'll read the whole thing out. For a species of aliens, oval eyes are dominant to round eyes. A homozygous dominant alien has a baby with a round-eyed alien. What is the probability the baby will have oval eyes? So step number 1 is to create a key. That means assigning letters. So I'm going to have capital A, and I'll have a lowercase a. And again, you can use whatever letter from the whole alphabet that makes you happy. I just like A's, so I stick with A's typically. So our first sentence typically is going to give us what's dominant and what's recessive. So oval eyes are dominant. That means, remember, dominant means capital letter. So oval eyes are going to be represented with our capital A because oval eyes are dominant. Oval eyes are dominant to round eyes, meaning that round eyes are recessive. Recessive is represented with a lowercase letter. So in this case, round eyes are going to be our lowercase a. That's step number 1. Step number 2 is to find out our parents. You're always going to have 2 parents, and each parent will have 2 letters because we have 2 copies of every gene. So each parent will have 2 letters. In this case, it says a homozygous dominant alien has a baby with a round-eyed alien. Those are our parents. Parent number 1 is a homozygous dominant. Homozygous means 2 of the same. Dominant means capital. So homozygous dominant is going to be 2 capital A's. 2 of the same capital letter. This alien has a baby with a round-eyed alien. Using our key, round eye is lowercase a. But remember, every parent has 2 letters, and the only way that this parent can have round eyes is if it has 2 copies of that letter. Because remember, if the alien has a capital A, it's automatically going to have oval eyes. So in order to have round eyes, it has to have 2 little a's. So that's step 2 complete. Step number 3 is to set up and solve our Punnett square. So we draw out our square. And remember, our Punnett square is going to tell us the possible combinations for the offspring. So for this square, there are 4 different combinations that the offspring could have. And I'm going to label them 1 through 4. Now I'm going to fill out my square. Parent number 1, I'm going to write along the top, and parent number 2, I'm going to write along the side. Parent number 1 has 2 capital A's, but it only gives one of its A's to its children. It could either give this capital A or this capital A. That's why I separate them here, because it only gives one to its children. Parent number 2 has 2 lowercase a's. It's either going to give the first lowercase a or the second. So again, I separate them. Next, I'm going to fill in my square, and this works just like a multiplication chart, where these 2 letters here are going to combine in this square to give me capital A, lowercase a. So this one will go here, this one will go here. For our next box, box number 2, they drop down like this. And again, remember your capital A's are always written first. So capital A's are always written first, even if there's a lowercase one present. You're going to write your capital A first. So in this case, all of them, 1, 2, 3, and 4, all the offspring are going to be big A, little a. Big A, little a is going to look like oval eyes, because big A equals oval eyes. If you have a big A, you have oval eyes. So I'm going to go ahead and fill that in. I'm going to, since this is my phenotype, I'm going to fill that in purple. So again, just because they have that large A, they have oval eyes. So we solved our Punnett square. Now we have to answer our question. Our question at the end says, what is the probability, that means it's going to be a percent, that the baby will have oval eyes? So I'm looking for percent oval eyes amongst the offspring. So I count up 1, 2, 3, 4 oval eyes. Out of the 4 possible, 4 out of 4 is 100%. 100% of these offspring will have oval eyes. That's our first problem. All right, let's go through another one. Reading the question. For a species of alien, tall eyeballs is dominant to short eyeballs. 2 heterozygous aliens mate. What is the expected ratio of tall to short eyeballs in their children? All right. Step number 1 is to create our key. I will have a capital A and I'll have a lowercase a. Okay, for aliens, tall eyeballs is dominant. Dominant means it's going to be the capital letter. So tall eyeballs is going to be my capital letter. Tall eyeballs is dominant to short eyeballs. That means short eyeballs is recessive, and therefore my lowercase letter. My next step is to find my parents. Each parent's going to have 2 letters. It says 2 heterozygous aliens mate, meaning both of my parents are heterozygous. Heterozygous means they have 2 different copies of the allele. So parent number 1, because they are heterozygous, they have a big A and a little a. It says both parents, 2 heterozygous aliens, both parents are heterozygous, meaning both parents are big A, little a. Now it's time to set up my Punnett square. Remember, this is going to have the 4 different possibilities for my offspring. I'm going to put parent 1 along the top and parent 2 along the side. Parent number 1 has big A, little a. They're either giving their child a big A or a little a. Parent number 2 has big A, little a. They either give their child a big A or a little a. When I fill in the inside of this square, it's going to show me all of the possible combinations that the offspring could get. So these are the possible combinations that the offspring could get from the parents. Now I'm going to go through and figure out what each of these looks like. Tall eyeballs is big A. If the offspring have a big A, then they have tall eyeballs. This one has big A, little a. But because there's a big A and big A is dominant, it covers up the small a, so this organism will have tall eyeballs. Same for organism offspring 3. But offspring 4, they have 2 little a's, meaning that you're going to have short eyeballs. So I solved my Punnett square, now I have to answer my problem. It says, what is the expected ratio of tall to short eyeballs? The way that we write a ratio is going to be the number of tall with a colon in the middle to the number of short. The number of tall that I have, 1, 2, 3. 3 of the offspring have tall eyeballs, and only 1 has short. So it's a 3-to-1 ratio of tall to short in these offspring. Okay. Let's do one more together. Going through the same steps. So number 1 is going to be to set up my key. I'll have a big A and a small a. Let's read. For a species of alien, 4 fingers is dominant. Dominant means capital letter. So my big A is going to be 4 fingers. 4 fingers is dominant to 5 fingers, meaning 5 fingers is recessive. Now I got to figure out my parents. It says 2 aliens with 5 fingers are crossed. That means both parents have 5 fingers. If they have 5 fingers is little a. The only way that you can look like your recessive phenotype or recessive allele is if you have 2 copies of it. So since both parents have 5 fingers, then both parents are small a, small a. I set up my square. Parent number 1 has 2 small a's. It's giving its child one of the 2. Parent number 2 has 2 small a's, and it gives its child one of those 2. Now I'm going to go through and fill in my square. Because both parents only have small a's to give, all of the offspring have 2 small a's. Every one of them that has 2 small a's has 5 fingers. Now I solve my problem. What's the probability of their offspring having 5 fingers? So 5 fingers, I count them up. How many offspring had 5 fingers? 1, 2, 3, 4. 4 out of the possible 4, that is 100%. 100% chance their offspring will have 5 fingers. Alright, so go ahead, I want you to pause the video and try to answer this one. Here in a second, I will go ahead and talk through this one. So go ahead, pause, try to answer this one on your own, and then I will go through it quickly. Okay, so in this problem, we're setting up our key. We'll need our parents. We'll need our square. Alright, so it says 2 heterozygous aliens are crossed. Both parents are heterozygous, meaning both parents have big A, small a. For this species, 6 legs is dominant, meaning big A is 6 legs. 6 legs is dominant to 3 legs, meaning 3 legs is recessive, which is my small a. I'm going to go ahead and set this up. Parent number 1 can give a big A or a small a. Parent number 2 can give a big A or a small a. I'm going to fill in my square. Here are the 4 different combinations that the offspring could have. If it has 2 big A's, that means it's going to have 6 fingers, or 6 legs. If it has big A, small a, it has a big A that's still 6 legs. Big A means 6 legs. 2 small A's means it's going to only have 3 legs. Now I have to answer my question. It says, what is the expected ratio of 6 legs to 3 legs? So again, my ratio is going to look like 6 legs, colon, 3 legs. I count them up. How many have 6 legs? 1, 2, 3. 3 have 6 legs. Only 1 has 3 legs. So here is my answer.